Good morning. Welcome to this morning's webinar. I am just going to allow a few more minutes for attendees to get online. Let's just give them a few minutes. Right. Good morning. I think we can start this webinar now. Thank you for joining me this morning for the Grade 11 Mathematics webinar. Before I want to start, I just want to do a little bit of an introduction. My name is Linky Young, and I am the Education Specialist of Mathematics and Sciences at Impact. Now, I just want to talk through a few pointers for this webinar. So if you are struggling to hear me, please make sure that your audio is on and your speaker volume is turned up. I just want to highlight this for the guys that won't be able to hear me, so that they can make the necessary adjustments. Right, let me test. Can everyone hear me clearly? You will see that there's a little hand that you can pick up, or put up. You can put up your hand. Let me see, can you hear me? Thank you. There's a few that is active already. Thank you so much. Right, you will be automatically muted when you join into this session. Should you have any questions, you can ask your questions in the question box on your dashboard, or you can raise your hand. Now, I will, during the session, open up times where you can ask your questions. Then I will unmute you, listen to your question, and mute you again afterwards. So during the session, keep your questions for that part, or when I ask you to please put up your hands. All right, we're quite a big group together, so to just make the operations a bit easier on our side. Right, if you don't know yet, but I think most of you do know if I look at the number of hands that is up at the moment, there's a little icon of a hand on your dashboard on your right or at the bottom, not sure where your dashboard is displaying at this moment, but when you click on that hand, it will put up your hand. So I'm going to take everyone's hand down, quickly put up your hands, make sure you know where is that button. Let me see, put up your hands, guys. Yes, great. All right, so all of you know where that button is as well. Right, so this webinar, this presentation, the slides is also uploaded for you in the handout box on your dashboard. So if you click on your handouts, you will see that the webinar is up there, the slides. You can download it now or during the webinar. I will remind you later again, but when this webinar is stopped, you won't be able to download that resource anymore. Okay, before I move on, I would just like to make sure that everyone that needs to be here is here. We have a bit of confusion between the mathematics webinars and the mathematical literacy webinars. This webinar is purely for mathematics. The mathematical literacy webinar will only be presented next week. You have two choices where to see your timetable. So the first one is it was sent out via email to our IMPA clients yesterday. And when you are an outside client or learner that is watching in, keep an eye out on our Facebook page. The next day's webinar will be communicated and announced on there. Right, so if you are a mathematical literacy student, you're welcome to leave this webinar and then tune in for the mathematical literacy webinar that will be presented next week. Right, the recording of this webinar will also be made available to our internal as well as external clients. Just keep an eye out for information regarding that. Right, I think that we can carry on. Okay, so I thought it well to start off and looking at the term 2 topics that you do have that we are going to look at in this term. Right, the first is trigonometry, functions, analytical geometry, and number patterns. Right, now if you are registered at IMPAC, you know that you would have already done analytical geometry and number patterns in term 1. If you are an external client, this is the 4 topics that you will cover in term 2. Now, for today, we are only going to look at trigonometry. Right, trigonometry is part of paper 2. Now, this does not mean that you will see no trigonometry in paper 1. The difference between the two is in paper 2 trigonometry, you will use trigonometric skills and you will do pure trigonometry in paper 2. Paper 1, it is integrated with your algebra. So you will do algebraic skills and use algebraic skills in doing the questions. So for example, you might find trigonometric expressions in a factorization question or in a simplification question that is in paper 1. Right, so pure trigonometry you will only find in paper 2. Right, so what is expected of you in the trigonometry topic for this year is your revision of grade 10 trigonometry. So 10, 11, and 12 forms part of the phase, you know that, the FET phase. So everything that you do from grade 10 to grade 12 build up onto each other. Right, so you can't forget what you have done in grade 10. That is why you will see grade 11 starts, every topic actually starts with a lot of revision before we move on to the next work. Right, then we will look at our fundamental identities, simplifying trigonometric expressions, deriving reductions formula, proving trigonometric expressions, solving trigonometric equations, the sine, cosine, and area rules. Right, so you know by now, I hope you know by now that trigonometry has to do with triangles. So it is actually trigonometry means the measurement of triangles. So all your trigonometry is in reference to triangles. Right. So in grade 10, you have only worked with specific types of triangles, and we call that the right-angled triangles. That is when your triangle have a 90-degree angle in there. And I've indicated that to you with the red box over there. Right. So all of the pointers that we've done over there focuses on a right-angled triangle. But what is new this year is your sine, cosine, and area rules, the last bullet over here. And that is where you will work with other types of triangles, like the acute triangle, where all of my angles over there are acute angles. Now, acute angles are angles less than 90 degrees, or you will work with an obtuse triangle, where one of your angles will be bigger than 90 degrees. So today, we will be looking at the first 3 bullets over there. Right, so this webinars will only be presented for mathematics every 2 weeks. So next week, you will only receive notes and no webinar will be presented. So your notes for next week will build on what we have done this week and then include the rest of these bullets that we did not get to during this webinar. Okay. Can I quickly see, is everyone still with me? You can put up your hands just to make sure everyone can still hear me and is part of this discussion. Thank you very much. Right, I am going to move on. So the first thing that we are going to do and look at is finding trigonometric ratios. Now this is purely grade 10 work, and I am going to move through this with knowing that you actually have done this before. So with finding trigonometric ratios, again, we're working with very specific triangles. We are working with 90-degree triangles over here. And I've indicated that again with a red box. Right, which is also important is that you are able to identify the different sides of my triangle. So the first side is the easiest. It's the side that is always opposite to my 90-degree angle over there. And we call that the hypotenuse. Now that will never change. My hypotenuse is always across or opposite my 90-degree angle. In trigonometry, it's also very important that we name and use an angle as reference. So I'm going to choose this angle here at the bottom and I am going to call it theta. Now, it doesn't matter what you call it. If it didn't have a name and you need to name it, you can name it any variable that you'd like. You can call it S, you can call it T, you can call it X. I am using theta and beta in this presentation just because it's the obvious angles that they usually use when naming angles. Right, so opposite this angle that I chose of theta, right opposite of that, we call the opposite side. The one next to him, we call the adjacent side. Right, so you are used to the trigonomic expressions by now, which is sine, cosine, and tangent. Now, you're probably not used to this whole word, but we're going to use this sin, cos, and tan. Right. Now, you will see that it never stands alone. It is always to reference of an angle, that angle that you are working with. Sin, cos, and tan can never, ever stand alone. You always need to write it as a reference to another angle. Right. So why do you think an angle and a reference to a specific angle is so important? So I'm going to show you 2 scenarios. The one we did look at right now, where we used theta, we identified the hypotenuse, the opposite side, and the adjacent side. So what happens if I choose another angle, which is not the theta angle that we've chosen now? So I'm going to choose the top one over there, beta. I'm going to call it beta. So my hypotenuse stays my hypotenuse. because it is opposite of my 90-degree angle. But now if I look at the opposite side, it will be there. Do you see that it is different from my previous one? And this is only because I chose another angle as my reference and not the original theta. The adjacent side will now be there. Right, so this is why it is so important to make sure that you stand at the correct angle of reference, or when you write down your answers that you use the correct angle to reference from. Right, so the following is absolutely stunning. This will never be available on a formula sheet. No one is going to give it in an information box somewhere on your papers. This you need to know off by heart. Right, we know that ratios can be expressed as fractions by now. Like a quarter is 1 part to 4 parts, and you can write it as a normal fraction as you're used to, or ratios we use with double, with a colon in the middle, right? Right, so in this case, we will write it as fractions. Okay, so sin will always be written as the opposite side over the hypotenuse side. Cos will be written as the adjacent side over the hypotenuse side. And tan beta will be written as the opposite side to the adjacent side. Right. So this you will only be able to do if you use the correct angle there as reference. So you need to look at what they are telling you, at which angle you should stand, and then do your referencing from there. So let's give them all a name or a number so that it's not so abstract. So with the hypotenuse, I said that I'm going to give it a length of 5. With the opposite, I'm going to give it a length of 3. And with the adjacent, I'm going to give them a length of 4. Right. I am going to give you 1 minute to write down on your own what would be the answer for sin beta, cos beta, and tan beta if I use this length that is given to you. So let's look at what you got as answers for this questions. I hope that all of you have got that. Right, so if we look at our sin beta, and I stand at my sin, the opposite side will be 3, and my hypotenuse will be 5. I hope that all of you have gotten that. Right, my cos beta, if I stand over there, will be adjacent, which is 4 over my hypotenuse, so it will be 4 over 5. And tan beta is my opposite over the adjacent, which will be 3 over 4. Right, quickly put up your hands. Did all of you get that? Show me. Did you get that answers? Well done. Good. Great. Right. So this is one way of doing this. The next thing I'm going to show you is another option that you can use in finding these ratios. It is absolutely up to you which one you would like to choose. Right, so I have shown you there a part of a Cartesian plane with a y and an x-axis, and I'm going to draw my right-angled triangle over there. Now I also need to choose an angle as reference to this. You will see we'll get in now, but your height of this triangle is your y value. Just in any other graph that you have drawn, the height of it is actually is shown on your y-axis. Right, the x value is on my x-axis, and then you have a reference to the hypotenuse that you are used to now. Do you see it's still opposite my 90-degree angle over there? And it is named the radius. So why do we call it the radius? So if you look at a circle and it starts, this triangle is drawn from the origin, meaning 0, 0, or the midpoint of the circle. This line actually indicates my radius. Okay, so I'm just going to remove that for now. I am going to choose this angle now as beta at this stage. Right, so sin beta is y over r. Do you see that it's still my opposite over hypotenuse? Cos beta is my x over r, which is my adjacent over my hypotenuse. And my sin beta is y over x. It's my opposite over adjacent. Now, it's absolutely your choice. You won't be prescribed which one of the two you may use or you can use. You can choose to work with the sides, opposite hypotenuse or adjacent, or you can use x, y, r, whichever one is the easiest for you. Right. You are going to use this to find sides and angles to right-angled triangles. And I'm sure that you actually got exposed to those kind of questions already in grade 10. Right. You're also going to make use of fundamental identities. Now, fundamental identities is the first identities that you actually learn when you are working with trigonometric equations or expressions and ratios. Right. So when you have a sine theta over a cos theta, now remember this theta is only reference to angles. It can be anything else. It can be A's, it can be B's, it can be betas, it can be X's. It doesn't matter. When you have a sine X over a cos X, that can be replaced with a tan theta. Right. So tan theta can either be expanded to sine theta over cos theta, or cos theta over sine theta over cos theta can be replaced with a tan theta. The other and the next fundamental identity is where I have sine squared theta plus cos squared theta is equal to 1. Now again, 1 can be replaced with sine squared theta plus cos squared theta. And sine squared theta plus cos squared theta can be replaced with 1, right? So you can use that interchangeably in your questions, whichever the question requires. You will know when you get there, especially when you need to simplify what is your needs in that question. Right. I just want to again have a look at our trigonometric ratios that we looked at and just remind you of their reciprocals. Why is it important? Like I said, with simplification of expressions, when you have that in question papers, you might need to interchange between the two, depending on what the question actually requires. Okay. So sin beta that you are used to now can also be written as 1 over cosec theta. Sorry, this beta should have actually been a theta. Your angles should correspond over there. Okay. Then cos theta is equal to 1 over sec theta, and tan theta is 1 over cot theta. Right, so this is the reciprocals to my normal trigonometric ratios. So I can actually take this if sine beta was 4 over 3, cosec will be 3 over 4. So you just write down the reciprocal of that ratio over there. Right, you're going to use that when you simplify trigonometric identities. Right, so let's look at an example or two of simplification of these trigonometric expressions. And before I carry on, let me just see that hands again. Everyone can hear me. Everyone is on track. Thanks, thank you. All right, so let's look at this example over here. So they give you this expression and ask you to simplify that. So cos squared theta over sine squared theta is 1 over cos squared theta minus 1. Right, so I'm sure all of you want to jump in and add a tan theta over there. But if you look closely to that question, it's cos squared theta over sine squared theta, where tan is actually sine squared theta over cos squared theta. Now you need to think about reciprocals and stuff like that. So firstly, I recommend that you start with your normal algebraic skills, which will be when you see a bracket over there. What does a bracket mean? A bracket means multiplication. So I am going to multiply in this expression over there. Right, so I've taken this cos squared theta over sine squared theta and multiplied it with 1 over cos squared theta. And I've multiplied it with the negative 1. So I will have cos squared theta at the top, sine squared theta times cos squared theta, and then minus this cos squared theta over sine squared theta. So I've used the distributive law to multiply in that term over there. Now you can see in the first term that I can cancel my 2 cos squared thetas with each other. And I'm left with 1 over cos squared theta minus cos squared theta over sine squared theta. Now, my denominators are the same. It means that I can merge the two fractions into each other. And note this 1 that stands over there. I can say that I have 0 at the top of the first term when I've cancelled that cos squared theta. I need to replace it with a 1. Right, so here comes the tricky part now. 1 minus cos squared theta. You need to think back to our fundamental identities that we looked at. So it should actually ring a bell to you that you have seen this before. So sin squared theta plus cos squared theta is equal to 1 is your fundamental identity over there. When I take the cos squared theta over to the other side, I will have 1 minus cos squared theta. And that is exactly what I do have there as my numerator. So I want to replace that with sine squared theta. Right, sine squared theta over sine squared theta, and you have that as equal to 1. Right. I am going to take a few questions on this example quickly. So if you have a specific question over here, please quickly put up your hand and let me see if I can help you. Okay, it seems like everyone is happy. I'm going to move on to the next example. Now they can also ask you questions like prove the following identity. Now, it doesn't mean that you need to do something totally different and go and study off a proof that you're used to with geometry. This proving of identities with what they ask you is that you need to split the two sides of the equal sign. So you're first going to work with your left-hand side and simplify that left-hand side to get to your right-hand side. So it's still a simplification question. You still need to simplify. Right, so I am going to take my left-hand side first. So left-hand side, and I'm going to start with that. So which is nice over here is that all of these are actually multiplying. It means it's one term, meaning I can cancel across, I can cancel top with bottom. So there's a lot of canceling that can start off initially. So I've just said multiplying and cancelling just to show that all of them are multiplying. So I can take the top parts and the denominators and put them all together. Right, so there's one cos theta that can cancel with one of the cos squared thetas. Now remember, cos squared theta is plainly cos theta times cos theta. So you can cancel it with one of them. My sin squared theta, one of the sine thetas can cancel with the sin theta at the bottom. And you are left with sin theta over cos theta. Right, so this is quite an easy identity, one of the fundamental identities that we looked at. And you know that tan theta is equal to sin theta over cos theta. It means that I can substitute the tan theta instead of that whole fraction over there. Now look over there. You have on your left-hand side, we only worked with our left-hand side, you have tan theta. And that is exactly what I want to prove, that this side is equal to my right-hand side, which is also my tan theta. In this case, you have answered the question that was asked and completed it. Right, I'm going to ask again, do you have any questions regarding this example? Carla Craft has a question, but you didn't turn on your microphone. So unfortunately, I won't be able to ask your question. If you get that right and you still have a question, you're welcome to put up your hand again and just ask your question. Further on, it seems like everyone is fine and you don't have any questions regarding this equation or this examples over there. Right. I did put together some extra practice for you guys. So just get you into trigonometry again after your grade 10 year. Please go and visit those two links and do that extra practice. You have a week to work on that. We also have a YouTube channel at Impact where someone is again explaining this work, give you a bit of practice and examples over there. So please click on the YouTube links that I've provided there for you. The top one is in English. The Afrikaans one is at the bottom. It's a replication of the English. It's just in Afrikaans. So if we do have some Afrikaans listeners, attendees this morning, they're welcome to have a look at that as well. Right. Please remember to download this webinar from your handout box. If you look there at the right-hand side on your dashboard, please download this slide so that you can go and look at the examples again, make some extra notes on there for you to study on later. Right. So I'm opening up the floor now if you have any other questions that you want me to answer. So please put up your hand if you do have any questions that you would like to ask. No one? Oh, there's one. There's one. Jacobus Potgieter.
I got a question. How many questions are in the extra practice?
There's quite a lot. So the one you will see is a website that actually replicates questions as you go along. So it develops as you go along. You can stop at any time that you would like to.
Okay, thank you very much.
Pleasure. Anyone else with a question? Yeah, I'm just going to open up my question box and see. Seems like someone asked a question over there. Right, so Tyron Harmse is asking if when you have written your trigonometric ratios, if you should leave it as a fraction or if you can simplify that further. You can leave it in fraction form. You will receive all your marks. It is a ratio, so you can leave it as a simplified fraction in the end. Right. Charles Kannemeyer shared that they didn't completely understand question 2. Please show me what you are struggling with, or you can send us an email at academics@impact.co.za and I will get back to you on that. You can download the slides in your handout box, Taryn. So just go to handouts. You will see that it will be over there for you to download. Someone said that Luca said that they have joined a little bit late. Yes, there will be more webinar lessons like this. In 2 weeks' time, we will have another mathematics webinar. The timetable of the webinars was sent late yesterday to our impact clients. If you're an external learner that is logging in today for the webinars, keep an eye out on our Facebook page where we will announce the next day's webinar for now. Right. Caitlin is actually asking when we are going to start to use values in your angles. You are going to use that in this year. So like I said in the beginning, so that the topics and the pointers that we didn't get to today in our webinar will be addressed in the notes that will be sent out next week. So we're alternating between a webinar and a note week. So this week is the webinar week. Next week, the follow-up will be extra notes, and I will carry on with trigonometry over there. I'm just going to check the attendee box quickly. I don't see any hands up for any questions. Carla Croft. Carla? Okay, it seems like Carla is not with us at the moment. Right, I am going to carry on. Let me see, there is a hand. Asanda. Asanda Pakati.
Yes, ma'am.
Yes.
When are we going? What day are we going to get the notes? The extra notes, ma'am.
Okay, so the additional notes that is being put together will only be made available by next week. So you will get all the information on that next week.
When next week, ma'am?
That will be sent out by our communications team. It will be available early next week. Just check the communication. Okay. They will send out communication. Okay.
All right.
Thanks,
Thank you, ma'am.
Bye. Pleasure. Bye. Right. Anyone else with a question this morning? Adam Tiki.
Hallo,
Adam?
kan jy vir my hoor?
Yes. Ja, ek kan jou hoor.
Ek kan nie Afrikaans praat nie. Is die lees in Afrikaans?
No, this session was in English.
Oh, okay. So you guys, it's only in English. There's no Afrikaans version.
There's no Afrikaans version as yet. We did get a lot of requests. I'm not sure how they plan to address that, but for now, the webinars will only be in English.
Oh, okay. Thank you.
All right, have a lovely day. Bye-bye.
Love you.
All right. I've talked to Asanda now. Right, I'm going to open up this box over here quickly. You are not required. So Daniel asked if you are required to do the questions. You're not required to do the questions. I'm working through the examples with you. The extra practice that I've put over there is absolutely for your own use. I'm not going to check if you have done that. That is for your own learning over there. As you're homeschooling, or if someone is signing in that is at a school but is currently not able to go to school because of the COVID, it's your choice. You can work through the questions if you'd like to. Mika, again, I'm not going to check if you have completed that activities. It's absolutely for your self-learning. Right, Boipelo said that she's struggling to find this extra work. You're welcome to go onto the guided learning platform of Impact. If you are not an Impact student, please just keep an eye out for the communication. You can also go to that YouTube links. It means that you will get onto our channel over there. There is a lot of extra work and a lot of extra explanations that is happening on that YouTube videos. Right. Yes, Mika, if you don't have any questions and you don't want to listen to the answers of the questions that is typed out, you're welcome to leave this webinar. I'm not going to do any content anymore. Right, RG asks that how many webinars there will still be for mathematics. Audrey, so op die oomblik het ons net vir hierdie week en dan oor 2 weke weer, aangesien die skole weer gaan aangaan, en as jy dan 'n impakleerder is ons guided learning platform vir jou beskikbaar waar jy al hierdie lesse ook kan kry en selfs ekstra lesse kan kry waarna jy kan kyk. Indien hierdie lockdown tydperk verleng gaan word, sal ons weer kommunikasie vir julle daar uitstuur. Lungile asks if the YouTube videos are available right now. It is available already. The channel was actually developed quite a while ago, so all of the videos is on there already. Shawana asks how important is trigonometry for the final examination. It is very important. It is a very big part of your paper 2 that you will write. So yes, definitely very important. You can't skip on your trigonometry. Luca is asking if this was specific regarding unit 11 in the textbook. Luca, ja, dit is deel van die eerste deel van tema 11 in jou handboek. So ja, dit was spesifiek vir dit. Dis hoekom ons gesê dat dit is net vir trigonometry. Right. If there is no more questions, I think that we are done with this session. Thank you so much for joining me. I hope to see you in 2 weeks' time again for our next session. And our topic will be sent out closer to the time. Please make sure to keep an eye open for some extra notes that will be sent out next week. And this will, of course, build onto the work that we have done today. Right. If you did not download your handout yet, please download it right now. We're close to ending this webinar. And if you are not registered with Impact, please contact us at info@impact.co.za if you would like some more information. Thank you everyone for joining. Hope you have a lovely day. Keep safe. Bye-bye.